All right, we left off here with the rock cycle. So what are the three types of rocks that we discussed last class period? Igneous, sedimentary, and metamorphic. And so we had this cooling and crystallization as the lava, as the magma comes out of the volcano and turns into lava. It created these extrusive and intrusive rocks. We have names for these rocks based on some type of chemical content. Then we have sedimentary, the three processes of lithification. So compaction, remember those layers are going to settle on top of each other. They'll get compacted, they'll get cemented and crystallize and form this rock. We went through these, talked about coal, and that is going to be into metamorphic rocks. It'll undergo melting and go back into magma. And so, y'all, we're talking like this is in one of those Paleozoic eras that this stuff took place, right? This isn't necessarily happening right at Mount St. Helens in Washington, right? This is like ages ago. We went over metamorphic, that it's going to undergo a temperature change, and we're going to increase the pressure. And eventually, from those rocks, we will start the soil formation process. So there are 5 soil forming factors. The first is going to be parent material. So which rock was the basis for the soil? Where did the rock come from? See, that's super tough with 6 on there, isn't it? Mm-hmm. And so, like, if I could get a page that was bigger, right? If I put a picture that made those a little bigger, it might be better. I don't know. Still working on that. Next, we have the climate. What was the climate that it formed in? Was it in Michigan, Newfoundland? Was it in Brazil? Did it form in Africa where it's really, really hot and they don't get a lot of rainfall? Was it in Georgia where it's really hot and they get a lot of rainfall? What was the climate like? We talked about those organisms. And so as macro and microbiota start to utilize some of the minerals in that rock, or maybe you get a deer that comes by with a hoof and breaks a piece of that rock off, just a little bitty piece, that piece will then disintegrate a little bit or weather easier, and it'll start to form soil. The topography. Is it upland? Is it in the lowland? How does that affect the soil formation process? So we have this parent material that breaks off from a cliff that falls, and it then begins to disintegrate in a wet climate with a lot of organisms, and then at the bottom of it, at the bottom of that kind of slope, that soil will form differently than in the upland. We typically farm in the valleys, not on the hilltops, right? And then finally, time. And soil takes a very long time to form. So while we had this rock cycle that took place in eons ago, that soil is just now starting to form. So from these soil formation processes, the factors, these are the factors. We have some processes in there that are going to determine the soil physical and chemical properties. So this is going to be kind of the direction that we're going to take in this module. We talk about the factors, we'll discuss the processes, and that's going to lead us into physical and chemical properties. So starting from the beginning, we have this rock, this parent material or bedrock that is rained on. We get some organic matter from some plant or something that fell off an animal as they were moving that starts to facilitate some more of this disintegration. You can see this starting to break down. We may get a bird that ate a berry and happens to land on the rock and leave some excrements and then move on. That seed germinates and starts to form roots and starts to break that rock down a little bit more. The plant dies, its seeds dies. That plant material is what forms that soil. So soil forms from the top down. Everything that goes on the top of it is what causes it to be the depth. So we have these different master horizons, and they are named fairly simple. Where are we at?
I don't think it's on.
Is it not in there? No one has the slide?
It's later. It's like 10 slides later. Yeah.
Okay. We'll go over it 10 slides later then. All right, so as I mentioned, I'm into drones. And so my first semester here, I was like, what'd be really cool is if I showed them some aerial pictures. This is right there on where I-40 and 111 intersect. So if you go out I-40 like you're going towards Knoxville and turn on 111, there's like this wall. I mean, it's Tennessee. Y'all are probably used to Tennessee walls. I'm not. I come from Mississippi where it's flat. So every time I drive by this, I'm looking for the soil that is forming. So we have this rock. You can see they cut out some of this, but if you start to look closely, you can see some soil forming, and you got these trees that grow in a place you didn't expect the tree to grow, right? You're like, how did that tree even get there? Again, there was a bird that dropped a seed that started to grow in that little bit of soil. And y'all, this takes like hundreds of years for this little bit of soil to start forming because it has to undergo those weathering processes. Some more pictures of that. We get these different colors in here based upon some movement, some zones of alluviation, some of the soil forming processes. So at one point in time, we had these different pockets and ion concentrations, and then that rock was compacted from the rock cycle and then formed. Here we have those trees growing out of almost nothing, and those roots are penetrating that rock and breaking that apart. Over time, that rock will end up breaking and starting to form soil. And then this is this big cliff over here. And you see down here we have nice green, and there are plants and things growing, and this is where we are producing hay. I'm guessing they're producing hay over there. But you probably aren't growing corn on the top. You probably aren't growing your plants on the top of a hill. Typically they're going to be in the bottom because that's where all the soil has settled. We have different types of parent materials. So starting with the base, we have residual and colluvial. And so residual is going to be formed right there. This soil that is forming is the residual. That wasn't carried from anywhere else. That rock broke, disintegrated, weathered, and that soil formed in place. Alluvial and marine are going to be having to deal with water. We have glacial till and wind transported and organic. So again, I showed here's some of this soil that is forming on the top of that rock structure. Develops in place from the weathering. And I mean, that happens everywhere. You're going to find residual soil and parent material just about everywhere you go because rocks all over the place. Then we have colluvial. And so that's kind of what happens at the bottom of the slope. So we have this rock that breaks and falls, and when it separates, like if it falls, 100 feet, like that impact is going to shatter that big rock that fell. So at the bottom we have colluvial. Residual in place, colluvial, it collects, just to remember. Colluvial, it collects at the bottom of the slopes. And so that's why that topography is so important. Next, we have those that are deposited by rivers or streams, and those are separated into like 3 different types. They're all fairly similar. So we have floodplains. That's kind of when the banks overflow, and there's a floodplain next to that creek. That's where those alluvial sediments are going to settle. Alluvial fans, that's kind of at the mouth of a river. I'm from the coast, so like in Louisiana, we call that the actual Mississippi Delta. That's where the river actually meets the Gulf of Mexico and starts to fan out. So as I mentioned, here is a stream bank that is forming an alluvial floodplain. Those banks overflow, and then the sediments start to settle out. And so what I like to think about is that if the Mississippi River actually starts somewhere in Minnesota. And so from Minnesota, it's carrying all the sediment that either runs off into the Mississippi, all the nutrients that are in the Mississippi. And so that river is flowing so fast that it's got a lot of sediments in it, right? And so it's picking up sediments all the way from Minnesota, and it's going all the way down. We get down into the Delta, and it's coming down to the Gulf of Mexico, and then all of a sudden it stops. Unstoppable force means immovable object. And so what happens is the sand, silt, and clay start to settle out at different rates. And so right here, kind of similar to that, we would expect the sand to settle first because it's heaviest. Next, that water would continue to move and those sediments would continue to move, and slowly but surely, the silt will settle out. And then finally, the furthest away, the clay is going to settle out because it stays in suspension for so long because it's so light. So the closer you are to a water body, you would expect to find sandy soil. Anybody live near a river, a large creek? Y'all got good soil over there? Yeah? Because all those sediments have settled out at a certain rate, and you can actually see where those are. Closer to the river, it's sandier. A little bit further away, it's kind of loamy. And then further and further away, it's clay. So the way that the sediments settle is going to dictate some of that soil. Those parent materials that get picked up and moved are going to dictate some of that soil. The Delta, the Mississippi Delta, what we consider the Delta, which is kind of over by Arkansas where they grow all the corn, cotton, rice, and soybean, is some of the most fertile soil in the country. Well, guess where it came from? Where'd it come from? Where does the Mississippi start? In Minnesota, right? So it's picked up all that soil that everyone's been farming that's got all those nutrients, and it settles out in a certain way, and they're able to farm extensively in that area because of the way that the Mississippi overflowed. You may or may not encounter some of these marine sediments, but just to kind of go over them, they have different, we got lithogenous, biogenous, which is kind of like fossils, hydrogenous, and so that's going to be more of your chemical precipitation type reactions, and then this cosmogenous is from space. And I don't really know the physics behind a soil particle traveling through the atmosphere and not burning up, right? But maybe it's a meteorite that happened to hit the earth that hit in Arizona with rock, that rock on rock shattered that meteorite, and then the soil started to form there. They don't grow a whole lot of crops out in Arizona. I just added another table in just so y'all could kind of get an idea of where we might get some of these things. That whole space thing cracks me up. Next, we have glacial till and wind-transported materials. And so, I guess just being from Mississippi is the only kind of thing that I know the most about. So remember I mentioned that we had the banks of the Mississippi overflow, and we have the sand that settles out first, and then we have the silt, and then the clay. Well, because Mississippi's flat, that wind flows pretty hard. And so it's going to pick up which one of those materials, sand, silt, or clay, do you think wind is capable of picking up the easiest? You got like a 1/3 chance of getting it right or wrong. It'll pick up the sand. So we're going to have some sand moving. Is the silt going to move too? And then also the clay, right? So it's going to pick up all three, and they're going to get scattered much the same way that they did with the water. So the sand will get picked up and blown a little bit, but it might get blown a little bit further. And so you might have something that looks like if we were to come from the river, I know y'all can't see it over there. Right, so we have that settling that I described, and then we're going to have some of the wind pick up some of this sand. And is all the sand going to pick up and go just over here, or is some of that going to fall out? So now we have a sandy clay. We have a silty clay. We have probably maybe some more sand. We can start getting this mixture. So it's just variable all over. And so we call those loess materials, volcanic ash. You can imagine that as that comes out, the wind is going to take that and settle it somewhere else. Organic deposits are going to be kind of our peats that eventually form into coal, like moss. Anybody here in horticulture? You deal with like peat moss, sphagnum moss, kind of those soil-like media. This is where they come from. I'll put that in there. So you might see these again as you're going about your horticulture career. So we have the moss, we have the herbaceous, which kind of gives us an indication about plants. Woody, we're going to expect trees and shrubs. And then some of these sedimentary are going to be those aquatic plants that die and settle on top of each other because they're growing in the same place they just died because the seeds dropped. Oh, Dr. Earhart put a clock back there. Everyone good here? Next, we're into climate. This one's going to impact the soil the most. And so for every 10-degree increase, for every 10 degrees Celsius increase, the biochemical reaction is going to double. But we also need water in order for that to happen, right? Water is the great solvent. So it can be hot as all get out, like in Arizona. Anybody been to Arizona? That out west is still hot, isn't it? I don't care about if it's a dry heat or not. 115 is hot. I don't care where you are. I've been out there, and I was like, I'm still sweating. But anyhow, they don't have enough precipitation to continue this process so that their soils break down. So they have a lot of sandy material that never got broken down. And then also this climate is going to influence the type of organisms and the habitat that is there, and also plant growth. They don't grow a lot of plants out there because they don't have enough water. So the plants don't put down roots that kind of break that apart. Also, in climates that have a more cyclical change, what we have is we have a piece of rock that breaks open a little bit, and rain gets in there and freezes. And when water freezes, it pushes that rock. I mean, ever so slightly, y'all. Like, we couldn't even do an experiment to see how much that moved. We're talking micrometers. But it thaws. Another raindrop gets in there. More water gets in there. It freezes and cracks a little bit more. We get more water. We get more cracking. That's why it takes so long for this to happen. So over time, eventually that rock breaks apart. There are going to be many different organisms that are going to play a role in soil formation. And they're slow rolls, right? Because, I mean, how much can an ant really eat? So each one of those organisms do play a role, but they take a long time to complete these processes, and they need the right environment in order to do that as well. So it's not just a one thing. It's a combination of all those formations. And then finally, we talked about topography. And so here's that picture again. Here's where all of our greenery is, and maybe a little bit of tree on top. But we have the soil starting to form. When it rains, that soil will erode and settle down in the bottom. And here we have more of our crops that are growing. So we have parent material, climate, organisms, topography, and we have one more. Which one am I missing? Time. It takes time. Those layers have to form and that organic matter has to decompose, and there's going to be processes that happen. And so it takes a lot of time and a lot of organic material. So the more crops that we grow, the more soil we are likely to form. And so going back to that big biodome, you got to think about it. You only get a certain amount of soil in that little dome. And it's up to you. I mean, you can't produce any more. It would take longer than your lifetime in order to produce that soil. So you're kind of stuck with what you got if you were in that situation. So we have this O horizon, which is going to be that top layer. Maybe I should start from the bottom. Here we have our parent material. Next we have the C horizon, which is going to be where that parent material started to break. We're going to have the B and the E horizon. Those are kind of both the same. They just started to separate out a little bit more. And then finally we have the A horizon. And so the A and the O horizon are typically going to be the ones that you're encountering unless you're in geology, which I don't think anybody is. Right? So you'll be dealing with like the top 12 inches of the soil and making sure that the nutrients in there are available to your plant. All right, kind of the basics of that. Next, we have the 4 formation processes. We have additions and losses. Translocation and transformation. So 5 forming factors, 4 forming processes. It's really hard making soil like fun. But I have had people tell me, like, you at least made it somewhat interesting. So this is kind of the boring part. As we start to get a little further into it, it might get a little bit better. So for our additions, you're going to think about things like leaves falling. You're going to think about the deposition of other parent materials. And so that's why we get this kind of variable soil formation, or kind of the way that they're spaced in the field. They're going to be variable. It's not just going to be consistent. So if you ever have problems, can't figure out why your crop's not doing well, blame it on soil variability. We're going to add some fertilizers that's going to kind of go with that biogeochemical cycling. That's going to make some of those processes either speed up or slow down. We've got to have water, so that's going to go with climate. Some of our losses, those nutrients and minerals, are going to go through the soil profile as water moves from the top to the bottom into our groundwater. The plants are going to take up some of that water and those nutrients, and then we'll also have some evapotranspiration. Our translocations, these are going to be illuviation, eluviation. Our organisms are going to turn that over when they crawl through the soil. They're going to move some of that. But it takes a really long time for a beetle to get from here to over there. So each time that turns, it sits there for a while, the beetle comes back, I got a mole in my yard I got to get rid of. It's constantly messing things up, right? So as it's moving through, it's making those changes. And then transformations. weathering and decomposition. Some of you might have read this in the soils around us, that the zone of eluviation, you can think that E means exit. So this is from the A horizon into the B horizon. The zone of illuviation. So this is going to be from the B horizon into the A horizon. Because what happens when it rains a lot? Let's think about the water table. What happens to the water table when it rains? I move up or down? It moves up. Okay, hold on. No. So when it rains, the water needs to move down to the groundwater first, right? When it hits the groundwater, and then let's say way over here somewhere else, it starts to fill that water table up, like kind of like how we had a lot of rain this past week. That filled that water table up, and this is kind of more in times of like drought. Maybe it rains over in one part of the city and not the other, or one part of the forest. Fills that water table. Well, the water table has to rise. So you were right with the going down. That's the eluviation. The water table starts to rise, and when it does, it picks up some of the minerals and nutrients that are in the B horizon, carries them into the A horizon. So we have the water table that rises and brings some of the B horizon into the A horizon. And then guess what? It'll rain, and that'll go back down. It'll rain again, and it'll fill back up. It'll go back down. We'll have a drought, and it'll rain, it'll go back down. So it's constantly changing. That pedoturbation is going to be that biological, physical mixing of the soil. And then salinization is going to be salts, right? Saline solution, salinization. And then alkalization, when we think of alkaline, I think about sodium. These two kind of go hand in hand, right? Because we have soluble salts, sodium chloride is a salt, saline solution. So these two are going to be kind of the same. These two are similar to each other. And then we have the organisms that are kind of doing all that together. Those are our mixing bowl, our mixers. Oh, we got weathering and decomposition. Weathering is fairly simple. We talked about that in the rock cycle. That is going to be what we talked about with the rock. That water gets in there and that little crack freezes, spreads it across, opens it up, and we get a little more water in there. We have more rainfall that hits that's eroding some of that rock based on the composition. You good, Hannah? Okay. Something that kind of interests me, I guess being from a specifically discussing this part right here with this weathering, when I go to these waterfalls, I've been to like 11 waterfalls this summer, and it just amazes me that some of those rocks are still there, even though the water is still just falling constantly on it. It's not like eroded away or anything. Like, have you ever seen something where it just drips on it constantly and starts to dig a little groove? So these rocks are formed so hard. They were compacted during that rock cycle process. Some of the rocks did break away. You can see them where they fell from the top and landed there. So something happened that just happened to break right there for whatever reason. Something in the rock formation process that was like a stress fracture somewhere that didn't quite solidify. So that broke and landed at the bottom of the waterfall. But they're still there after all of these years. So the way that rock formed, the water doesn't even break it down. But some of the rocks it did, right? It just all depends on the way that rock was actually made through that lithification process. Decomposition is going to be where we talked about the minerals and the organic materials. Humification is when we convert that leaf material from a leaf into that nasty, gooky kind of, you really can't tell what it is, you just know that it's nasty. So what we call humus. We'll probably discuss mineralization the most later on in the semester, and that is where we have the minerals are released from organic materials and converted from an organic form. And how do we determine if something is organic or inorganic? My chemistry majors?
Carbon.
If it has carbon. So we're going to go from a carbon-based material. It is going to undergo a transformation from a carbon-based material to a non-carbon-based mineral. So the microorganism is going to use the carbon and then spit out the rest, essentially. During this mineralization process, that stuff that gets spit out the rest, it will then form a secondary mineral or a synthesis. It will form a new mineral. If you continue further into like soil chemistry type, I just had a email run across my desk. There's a company, I want to say it's in Nashville, Runyon Industries, that's having some problems with nutrients that are in their water, right? So they have this wastewater. I guess maybe they might be a greenhouse or whatnot. So their wastewater, like the stuff that falls through after they've watered, the nutrients that leach out, they need to get that clean. Soil chemists use this in order to synthesize new materials. So you can have phosphorus or nitrogen or some heavy metal, and if you know how to do the chemistry, you can make those combine. They will settle out, and you can send that water out that's clean. That's kind of what my PhD was. That's a brief overview. So if you know how to do the chemistry and you can synthesize these new minerals or compounds, they'll settle out. You can clean that water a little bit better. I think we're going to stop right there for chapter 3. I know we got lab right after this. I want to make sure y'all get the opportunity to maybe catch something to eat, use the bathroom. So the first section of lab is like at 12. And then I think the next section is at like 2:30, something like that. I'm not likely to be in there the whole time.